All right, today we're doing 11.3. We're going to work on 11.3 for 2 days, today and tomorrow. And yesterday we talked about the probability of something happening. So like, for example, if I said, if you rolled a die, and I said, what's the probability of getting a 3? What would you say?
How many times did you roll the die?
Once.
Yeah.
1 out of 6. So the probability of something occurring is out of rolling a die would be 1 out of 6 to get a 3. Today what you're going to talk about is multiple events. And if I said we had event A and B happening, today you're going to learn how to find the probability that A and B occur, or that A or B occur. So it just depends on what the problem is. You're going to have to know whether or not the two events, if they're independent of each other or dependent. So let's first talk about whether the events that you're doing are independent of each other or dependent of each other. So what does independent mean? Independent, that means that the two events have nothing to do with each other. For example, if you roll a number cube, and a number cube is a die, and then you spin a spinner, this does not matter. It doesn't matter what you get here, it's not going to affect what the spinner says. Okay, so we say that those two events are independent. But if I pick the flash card and do not replace that flash card, and then I pick another flash card out of the same deck, those are dependent of each other, because the second event, when you pull the second card, the probability is going to change because you pulled a card out. So does that make sense? So if the two events are independent of each other, the two events do not affect each other. Okay? And if they're dependent of each other, then then the second outcome is affected because you did something to it. So here we go. Got it? 1. You select a coin at random from your pocket. So picture you have a pocket full of coins. And then, read this, it says, then you replace the coin and select again. If you replace that coin, does the second pick depend on the first? No, they're independent. So these two are independent events. And they're independent because the number of coins is the same after you replaced it. So you might want to write the number of coins is the same after you replaced it. So if the two events are independent of each other, what you're going to do is multiply. I want you to start thinking about this. You're going to multiply the probabilities. So if one event does not affect the other, it's not going to change the outcome, then you multiply the two individual probabilities, and we'll do that in a minute. But right now, let's decide 9 through 12 whether these trials are independent or dependent of each other. So let's talk about it. Number 9, if you selected a month at random, so January to December, and then you select a number from 1 to 30, are those two events, does one depend on the other? No, they're totally independent. So this is independent. Two independent events. So in that case, if you were doing probability, you would multiply the two. Number 10, a month is selected at random, and then a day of that month is selected at random. A day of that month.
Dependent.
That's dependent. Yep. Okay, how about 11? A letter of the alphabet is selected at random, and one of the remaining letters is selected at random. How about the color of a car is selected and then the type of transmission is selected? Independent. Okay, so flip to the back side. Here's a good example of two independent events. So you're at a picnic and there's 10 diet drinks and 5 regular drinks. How many drinks are there? If there's 10 diet and 5 regular, 15 drinks total. Okay? Then there's 8 bags of fat-free chips and 12 bags of regular chips. How many chips are there?
It's like 20.
20 bags of chips. It says if you grab a drink and a bag of chips, what's the probability that you grab a diet drink and a fat-free chip? So since these two events are independent of each other, one doesn't matter. It doesn't matter if you pick diet or regular, as to if you pick fat-free chips or regular chips. Those two are independent events. So what you do is figure out the probability of picking a diet soda. How many diet sodas are there? There's 10 out of 15. And how many fat-free chips are there? There's 8 out of 20. So you take the individual probabilities and you multiply them together if they're independent events. Now make sure you can write this as a fraction, as a decimal, and as a percent, okay? So in this case, it's 26.7% chance that you're gonna pick a diet soda and a fat-free chip, okay? So let's practice these on this page, 13 through 17. These are all independent events. So what would you do if you were asked to find the probability of Q and R? All you would do is take these individual probabilities and do what with them? Multiply them. Tell me what you get.
1/6.
What is it?
1/6.
1/6. You are correct. Now, make sure you understand that this number is a reduced fraction. It can also be written as a decimal and as a percent. So why I'm pointing this out to you is because on your multiple choice final exam, it may be written as a fraction, it may be written as a decimal, it may be written as a percent, so be flexible, okay? How about 14? What's the probability of Q and R? So picking this, 12 17ths and 3 8ths. That's a 7. What would I do? Multiply them. I can see that 4 goes into 12 and 8. 4 goes into 12 3 times. So 3 times 3 is 9, and 17 times 2 is 4. Questions? How about number 15? What's the probability of Q and R? Well, it's 0.6 times 0.9. What's 0.6 times 0.9? 0.54, or 54%. And the last one, what's the probability of Q and R? Anyone want to give me that one? 2/7. Okay, now read this story problem. Number 17. You have 5 books in your bag. 3 of them are novels, 1's a biography, and 1's a poetry book. So you have 5 books. 3 are novels, 1 is a biography, and 1's a poetry book. Today you're going to grab a book out of your bag, and you're going to return it to your bag. Okay? You're not returning it to the library, you're putting it back in the bag. You're taking a book out, and then you're going to put it back. I want to know what's the probability of if both days you pick novels. So you have to figure out probability of it being novel and probability of a novel. Well, how many novels are there? 3 out of 5. And since these are independent events, because you're returning it back to your book bag, you're gonna multiply these two and you get 9/25. If two events cannot happen at the same time, we call that mutually exclusive. And if they're mutually exclusive, the probability of A and B is 0. For example, here's an example of mutually exclusive. If I have a die and I ask you to roll it and I say, what is the probability that you get a 2 and a 3? It's 0. You're never going to get a 2 and a 3 at the same time. You're going to get a 2 or a 3. You could get a 2 or a 3, but not a 2 and a 3, okay? So when two events cannot happen at the same time, we say that they're mutually exclusive. So let's talk about these. So we're gonna discuss what's mutually exclusive, what can't happen, to what is not mutually exclusive, and that's confusing, not mutually exclusive can happen. So, does everyone understand that? Mutually exclusive can't happen, not mutually exclusive can happen. So think of it that way, that's how I have to remember it. So here's two examples. Here's problem 3. A, it says, can you roll a 2 and a 3? Can you? Can you roll a 2 and a 3 at the same time?
No,
No.
no way.
So we say these events are mutually exclusive. By the way, when they are mutually exclusive, when one does not depend on the other, it's gonna be, you add up the two probabilities. When they're not mutually exclusive, for example, can you roll an even number and a multiple of 3? Yes, you can. So these ones are not mutually exclusive means you can do it. You can do it. Can you roll an even number on a die and it also be a multiple of 3? Yeah, 6. 6 is an even number and it is a multiple of 3. Do you get this so far? So what about the next one, number 3? Let's talk about these. Are these mutually exclusive or not? Can you roll an even number and it be a prime? Can you roll an even number?
No.
0?
Yes.
2.
Oh.
2 is an even number and it is also prime. So this one we say is not, good job. That's these get tricky. These get tricky. Not mutually exclusive. You can do this. You can do it. How can you do it? 2 is even and it is also prime. How about the next one, B? Can you roll an even number and a number less than 2? No, this one is mutually exclusive. You can't do it. It's impossible. Can't do it. Okay? So now let's read 18, 19, and 20. Let's talk about mutually exclusive. So mutually exclusive, you can't do it. Not mutually exclusive, it should be the other way around, shouldn't it? I think not mutually exclusive should mean you can't do it. So mutually exclusive, you can't do it. Not mutually exclusive, you can do it. How are you gonna remember that? You're just gonna remember it?
Say opposite.
Yeah, opposite, that's what I would think, opposite, exactly. How about 18? If you were to roll 2 dice, can you tell me, can you get the 2 to be, can you get the sum to be a prime number? Let's talk about what is a prime number. 2, 3, 5, 7, these are prime numbers. Not 1. Not 1, 1 is not prime. 2, 3, 5, and 7 are prime numbers. So, question. Can you roll 2 numbers, can their sum be prime, and the sum be less than 4? Can you do that? Can someone give me an example?
1 and 2 to make 3.
2 and 1?
Mm-hmm.
Yep. 2 and 1, that gives you 3, and that is less than 4. So we say this one is not mutually exclusive. Because you can do it. You can do that one. Okay, how about 19? The numbers are equal and the sum is odd. So if the numbers are equal, here's your 2 die. 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. Well, if you added these up, you get 2, 4, 6, 8, 10, 12. All of the sums are even.
Mutually exclusive.
So this is mutually exclusive. You got it. Next one. Can you give me the product greater than 20 and the product is a multiple of 3? Can you find two numbers on a cube that their product is 20, but their product is also a multiple of 3?
6 and 4.
6 and 4, that's the one I thought of, 6 and 4. So 6, if you got a 6 and a 4, that product is greater than 20, it's 24, and their product is also a multiple of 3, because 3 goes into 24. So we say these are not mutually exclusive. We can do this, and I keep writing it, can do it. Okay, now, so if you can't do the two events at the same time, they're mutually exclusive. If you can't, for example, here's a good one. You're only allowed at the school to take one foreign language each term. You can only take one. So my question is, can you take Spanish and French? No, they're telling you you can only take one foreign language. Now, they tell you this is an experimental probability because they said 37% of the students take Spanish and about 15% of the students take French. So what's the probability that the students at random chosen is taking Spanish or French? They're taking Spanish or French. When you're doing a mutually exclusive probability, you add the two individual ones. So what you do is you figure out the probability of Spanish, which they gave you, it's 0.37, and the probability of French is 0.15, so the probability of taking Spanish or French is 0.52, 52%. So flip it over. Let's answer got it. So now they're telling you at this school, 9% of the students take Chinese. So, and again, you can only take one language at a term. So what would be the probability of taking Spanish, French, or Chinese? What would you do? Spanish, French, or Chinese, what would you do? Anyone know? You're gonna add them up. And I believe you get 0.61.
How'd you get the rest of those numbers?
These two were on the prior problem.
Okay.
These two were on the problem number 1.
So that was given to you?
Yeah. The probability of taking Spanish was 37%, and French is 15%. So now the next 4 problems are, they tell you they're mutually exclusive. When they're mutually exclusive, you add them. If they're independent, you multiply them. I want you to get this, we're gonna work on this another day tomorrow. So can you tell me, if I tell you the probability of event S happening is 5/8, and the probability of event T happening is 1/8, and they're mutually exclusive, what would you do with 5/8 and 1/8? You add them, and what do we do with all of our fractions? Reduce them. So what do you get? 3/4. Next. If I say the probability of event S happening is 3/5, And the probability of event T happening is 1/3. What would you do with these two? Add them. Well, how do you add two fractions? You gotta get a common denominator. So 9/15 plus 5/15 is 14/15. And what about if they give it to you in percents? 12% plus 27%. That's easy. 39%. And we have a story problem. About 30% of the US population is under 20 and 17% is over 60. Can you be, these are mutually exclusive, because can you be a person under 20 and over 60 at the same time? No, one or the other. So what's the probability that a person chosen at random is under 20 or over 60? Well, what you do with these two is you do what? 30% plus 17% is 47%. Okay, now, if they're not mutually exclusive, this is what you have to do. You have to figure out, if I say A or B, but it could be both of those. We could have both of them. What you do is you add up the two probabilities and then you subtract the probability of both of them at the same time. That's what you do when they're not, use this formula when they're not mutually exclusive. If it's mutually exclusive, if they both can't happen at the same time, like the probability of being 20 and 60 years old, or 60, you can't do, those are mutually exclusive, so those you add. But this example, P, probability of A plus probability of B minus the probability of A and B, that one is they're not mutually exclusive. So for example, and this did not come, the colors are not here for you, but I want you to, I'm gonna have you write this. You have these tokens in a dish, and they're different colors. And by the way, see this round one right here? It's green. This is green, and this square is green. These three are red, and I believe this one's orange. This one's yellow, and I don't know what color that one is. Blue. Doesn't matter, it's not one of those. Okay, so, suppose you reach into this dish and you select a token at random. I want to know what's the probability that the token is round or green. Well, we have some that are round. We have some that are square in green. So are these mutually exclusive? No, they're not. Okay? So if I asked you to pick something that was round and green and there was nothing that was round and green, then they would be mutually exclusive. But you can find something that is round and green. So what you do here is you would figure out the probability of each one separately. So what is the probability of getting a round token? Well, let's count all of, there's 9 tokens total. How many are round?
5.
There's 5. 5 out of 9 are round. How many are green?
3.
There's 3 that are green, 3 out of 9. And now you're gonna subtract the ones that are round and green. How many are round and green?
3.
3. No, 2.
2.
Oh.
2. This one's square and green. 2. So what is 5 nines plus 3 nines minus 2 nines? It's 6 nines. And then you can reduce it to 2/3. So what's the probability of picking a round or green? You do round plus green and round minus round and green. So let's do the next one. Same dish. and it's still not mutually exclusive. Okay, so I wanna know what's the probability that the token is square or red? So what you're gonna do, write small. Probability of square plus the probability of red minus the probability of a square and red. So, how many are square in this situation?
3,
3 out of 9. How many are red?
1.
3.
There's 3, these 3 are red. And how many are square and red?
1.
There's only 1. So 6 minus 1, this is 5 ninths. Try the next one. What's the probability that the token is green? So you want probability green plus the probability of square and minus, whoops, shouldn't use a pen, minus the probability of green and square. So what's the probability of green? There's 3 ninths. What's the probability of a square? How many are square? 1, 2, 3 ninths. And how many are green and square? 1. Again, this is 5 ninths. Green and square. Sorry, the color wasn't. Okay, the next are, these ones are, you're rolling to a number cube. A standard number cube is tossed. Find the probability that you, and these are not mutually exclusive. Not mutually exclusive. Because you can be a 3 and an odd. So I want to know what's the probability of getting a 3 or an odd. So you do a probability of a 3 plus probability of an odd minus the probability of 3 and odd. So how many 3s are on a die? How many?
1.
1. How many odd numbers are on a die? 3. 1, 3, 5. And 3 and odd, there's 1. What's your answer? 4? Next one. Probability of a 4 or an even number. So the probability of a 4 plus the probability of even minus the probability of 4 and even. So how many 4s are there? 1. How many even numbers are there?
3.
And how many are 4 and even?
1.
And this one again is 3/6 or 1/2. Next one. Probability of even or less than 4. So I need the probability of even plus the probability of less than 4 minus the probability of even and less than 4. How do you like how I wrote that? Probability of even. How many evens are there?
3.
3. How many are less than 4? 3. And how many are even and less than 4? 1. Minus 1/6. What do you get? What's this? What's 3/6 plus 3/6?
5.
5/6. Okay, try the next one. 28. What's the probability of an odd or greater than 2? Now, these are not mutually exclusive because you can be odd and you can be greater than 2. So what's the probability of an odd number? How many odd numbers are there on a die?
3.
How many numbers are greater than 2?
4.
3, 4, 5, 6, there's 4. And how many are odd and greater than 2? So there's 3 and 5, so 2. So what's this answer? 5, 6. Okay, next one. How about probability of odd or prime? How many are odd?
Three.
3. How many are prime?
3. 1, 2.
We have 2, 1 is not prime. 2, 3, and 5. There's 3.
Why is it 1?
And how many are odd?
Why is it 1 prime?
It's not. It just isn't. I
It-
know.
it-
I think it should be, but it's not. It has to be 1 and itself, and they don't include 1 as being prime. The
What's prime
definition of prime is not. We had this discussion 4th hour, and we looked it up, and 1 is not included. 2 prime, and that's why, did I?
Why is it? There's no reason that it's not? They're just like, nah.
It's
'Cause I
just
mean, it
not,
still
it's just
can't
not
be
part of
divided
the
by
definition. Prime numbers are numbers that are divisible by 1 in itself, I know, they just don't include 1. They
But it
start
is
with 2.
divisible by 1. And
I
1 is
know, I
itself.
agree, I didn't make it up. I'm not the boss, I'm just the messenger. Odd, so odd is 3/6, prime, there's 3 out of 6, and prime would be 2, 3, and 5, that's what they count. And now, how many are odd and prime?
2.
2.
And so what's your answer? 4, 6, or 2/3, and that is the answer. And the last one. How about, what's the probability of a 4? Well, first you wanna make sure, can you have a number that is less than 6 and could it be 4? Yeah, you could, so these are not mutually exclusive. So if it's not mutually exclusive, you do the probability of a 4, how many 4s are there? How many numbers are less than 6? And how many numbers are 4 and less than 6? What's your answer? 5, 6. Guess what?
No.
You guys are done.
Hey!